Hello, Professor. This is Vinod Venugopalan Nagarajan, and this is regarding our big data project presentation. So we have decided to go on with the big data analytics as part of this final project. So in this final project, we have obtained a data set, California housing data set. The California housing data set is a typical data set wherein we determine the median sales value of houses in a particular location based on several other factors like rooms, household income, age, and so on. So in this data set, we have tried to do a similar kind of prediction. So based on the other features, we are trying to predict the median housing value of this California housing. And then in this data set, what we have done is like initially we imported the data as we do any typical analysis. We went through the initial pre-processing phase. We understood the data with visualization, and further we understood the best kind of standardization and other necessary measurements to get the data into the standard form with the scalar. And then further we also run through specific models required to fit this particular data set and provide a higher accuracy on the prediction column. So in this data set, we also did the big data analytics part of this project comes with the cloud implementation. So we have imported the data set into Amazon S3 bucket, and from there we have imported the data set for this data analysis. Further, we also run the EMR in Amazon Web Services to get the Spark clustering done in the Amazon Web Services. So, as part of this final project, we have used PySpark and Amazon Web Services as the technology stack, and we are running this data set to find the median house sales. So I would like to talk about specifically the cloud part of this particular project. So what we have done is we have uploaded these files in the Amazon S3 bucket. So if you see here in the Amazon S3 bucket, we have these four data files: California housing domain data domain and the Python file. Further, we have created a bucket. In this case, like we have created this bucket called Vinod Raj, and further we have updated the code accordingly. So in this code, like if we see, we have had this S3 location provided in our code, so that the data itself, like it is picked from the cloud, and the analytics is done on top of the cloud cluster with the EMR, and then it provides us the results. So even if this is a small data set, our objective is that like the analytics should be possible across a tremendous or a large number of data sets with millions of rows. So let's go through the EMR part of it. So for that, what we did is like we got this. Let me go to the Amazon EC2. So this is the EC2 dashboard. So in here we have created a instance called big data. I can go to this in the EMR. So if you see here, we have created several clusters as part of like this assignment's implementation. So this is the working cluster which we finally created to run this part of the code. So in this cluster, like we have utilized M4 large. This refers to three cores and one master and two cores running at 8 gigabyte size. So this is a moderate kind of a cluster. So we created this cluster, and then like we operated it using telnet. Authentication is done using telnet. So in here, like if you see, the EMR is invoked using the telnet. I can probably exit this and redo this. Mm. First, let me quickly run through this file during the presentation, and then like we can do it from the beginning if you want. So let's do this. So in here we have the Amazon bucket wherein we have the. Let me just try to. As we see, like we saw those files for this California dataset in S3. So we are trying to copy the files from S3 to EMR here. So we have that cal underscore housing data which we showed earlier in this video. So I'm just copying those, downloading those files to EMR. So data file is downloaded. Now let's go with the domain file. Again, this is downloaded now. Let me go with the next file, that will be the Python file. So the big part of the file comes from big data project, which will be explained earlier, but just for the demonstration purpose of this cloud implementation, I'm using this calcode py file. Again, this is downloaded to EMR now. Now let's do a Spark job submission. Okay, so now I'm submitting this job here. So we see the Spark job running on cluster with Amazon Web Services. So in this part of the code, like we are calculating the root mean squared error of this prediction. So it was 86 point something while we run it on Python. So let's quickly check. Right. So as we see here, the prediction here is that 86921. So we will run through the same piece in our Jupyter notebook to just check the results. So I would have my rest of the team members to present the other part of the code.
Hello, Professor. I'll be doing some part of the code walkthrough of our analytics. So to start off, we load two data sets. Like the first file has the actual data, and the second file has the headers for the our data set. So the headers for our data sets are shown over here. And if we check the first two rows of our column, of our data set, we can see over here. Then we convert a cell in a RDD into each and every line, so we can do analysis on it. This is done by a map function over here, where we split the cells in by comma, and we take the first two values to check whether it has been done rightly. After that, we convert our RDD into a data frame so that we can do our analysis on it, and we use a show method to see all the variables and the data in our data frame. After that, we check the schema of our data frame, and as you can see, all of our variables are of the string type. So to run models on them or to do analysis, we'll need to convert it into float, and that's what we do after that. And as you can see, we have converted it into float. So we'll just run a simple select statement on a data frame to see the population and the total bedrooms that are there. After that, we group the median age of the houses and try to find out how which age group has most number of houses. To better understand this particular statement, we have done a histogram later on. So to start off our exploratory data analysis, we will be using the matplotlib library of Python, and we'll also be using pandas. So the first graph is a histogram which we do on the housing median age, and as you can see, the highest number of houses are between the age group 15 and 40 to 42. So we'll use this range and do another graph to check which is the accurate uh, house age which has the maximum number of houses. So the age group is 30 to 38, which has the maximum number of houses. After that, we run a histogram on the median house value and see that the maximum houses lie between the values 1 lakh to 2 lakh. So again, zooming in to those values, we can see that the maximum house value lies between 1,60,000 to 1,80,000. After that, we use both these variables to check if there's any relationship between them. And as you can see, the points in the scatter plot are distributed throughout the graph, and we can say that there is no relation or clear pattern is derived from this graph. Finally, in our EDA, we create a correlation matrix and use heat map to display the correlationship matrix. So over here, the light colors demonstrate that there is a less relationship between the variables, and darker color uh, represents there is a high correlationship between the variables. So as you can see, most of the colors are dark, so the variables are not that correlated with one another, and so that is why we have used all the variables in our analysis. So and these are the actual values of the correlationship between the variables. So the next will be the feature engineering, which will be explained by my teammate.
Good afternoon, Professor. I will be explaining about the machine learning models that we run using this dataset. We do some feature engineering. There are columns in which the dataset is not uniform. For example, the house value is in hundred thousands, but the other columns are in small numbers. So we divided by 100,000 to make it uniform. And this is the first level of scaling. Then we create new features, for example, rooms per household, population per household, bedrooms per room. We feel these features might be more important in predicting the value of a house, so we create that manually. Then this is just creating a data set. Then we convert the data into a dense vector. Our data set or data which we load into the regression model in PySpark, it should have labels and features. So the first step in that is creating a dense vector. Then we standardize and scale the features using the package. Then the data set is split into training and testing with 80-20% ratio. Then comes the model running. We run a linear regression model. We have labels and predictions. Labels are actual values, predictions are the values that are outcome of the model. So as you can see, the predictions are not so good. These are the coefficients that we get for different features. The root mean squared is the model evaluation metric for linear regression. As you can see, it's 0.87, which is very high considering the labels. So we feel we should run a different model, say a random forest model. So we run a random forest model, we convert that into a data frame, take necessary features, we do feature transformation, we create a labeled point vector. Then we run the random forest model, we find that the predictions are at least better. The labels are 4.56 and predictions are 4.16. So there is some improvement in the prediction. As you can see, the mean squared error is reduced. The training error is less because the model is kind of overfitting. So we see the data set running with a different model such as gradient boosting trees. So we do the same process, then we run the model. Here you can set the number of trees that you want in each model. As you can see, when you have 3 trees, the mean square error is 0.58. So we try to increase the number of trees. So when you run with 100 trees, it's 0.42. So as the number of trees get increased, we get a better performance from the model. So these are the analytics we have done in this data set. The same has been done in Amazon clusters. So ideally what we have done is we are trying to predict the housing prices given a data set. So our model can be used to determine the price of house when someone wants to buy or sell a house based on these weights for the features. Thank you, Professor. This is our big data final project.